Greetings and welcome to a video tutorial on Unity. In this one we're going to cover creating an FPS counter, mainly to get used to scripting in Unity. Now, a couple of notes on this one. First, it's going to be fast. This has already been covered in class for my students. Not to mention, frames per second counter, not that hard to implement. Second, I'm using Unity 3.5x. Our school has not upgraded to 4 yet, hence why I'm not using the most latest version. I also prefer to do my coding in Visual Studio, using specifically Studio 2012, since I'm on a Windows 8 machine. Visual cosmetic difference. This works obviously just as fine in Mono as it does in Visual Studio. So, let's get moving with this. Anytime we want to program something, we always want to have a plan. So I've got a star UML state diagram here to outline the logic that I want to implement for this frames per second counter. We've got our frame start. We're going to update our time. We're going to update our frames. We're going to check our time to see if it has exceeded a certain target value. If it has, we will then update our FPS. We will reset our time, reset our frames, and then proceed to wait for the next frame to come around. If our time has not exceeded this target value, then we'll just simply spin until finally our time does exceed this target value and we go through and do the updates. Planning your logic out like this for programming is of the absolute most critical importance. Sometimes when you don't know what it is that you're needing to do, obviously you can't do this. You just need to go in, write code, experiment, try to figure out the syntax, try to figure out what exactly it is that you need to do. But once you get that idea, you have got to come in, even if it's on a piece of paper, sketch it out. Sketch out your logic. Decide what it is that you need to implement. Because this tells us a lot right here. I know I need something to track my time, and the more I look at these things here, I realize that time's probably not a really good thing to call this. I should probably call this elapsed time, or something like that. I need some way of accessing delta time. I need to know what the time was since my last update. Thankfully, Unity gives us that really easily. I need something to keep track of how many frames have gone by. I need something to track how long I need to wait in between updates. I need a variable to actually store the FPS information, so that way I can do whatever it is that I want to do with it, write it to the console, or write it to the screen using a label, file, whatever. And of course I need to reset my time and my frames. If I don't do that, it'll really just mess up everything. And I'm going to need some sort of logic here to check, do I need to do this? Obviously an if statement right here, and waiting for the next frame, just looping on. And since I can see here that I need to be looping on this every single frame, I know from at least a Unity point of view that I need to drop this into the update method. Alright, so that's our logic. Let's hop over to Unity, brand new project here. I'm going to go ahead and create a script. I'm going to call this FPS demo. Creates our empty script here. Now, I prefer to work in Visual Studio, like I said at the start, but Unity by default does not immediately create the project files, so I am going to have to open this once in Mono to create the actual project files, and then I can go in to open it in Visual Studio. Now, the location of these files is pretty simple. Let's see, I got this in a different spot. So you go into the folder that has your project, not into the assets folder, just the main root folder of your project, and you should see your files. You just want the regular old solution file. And then expand out your assets folder, and hey, there's the code file. Alright. So going back to look again at our logic here, I got elapsed time, frames, target time, and an FPS. Alright. So let's get this in here. These, of course, need to be class level variables. Most of them I'm going to make private. So let's see here. Int frame count. Start that off initialized to 0. A float. Elapsed time. Of course, we'll start that off as 0. Always remember, if you put the decimal in, you need the F for floats. Otherwise, the compiler will assume a double. I'm going to need my FPS. I'm just going to make this an int because I don't care about partial frames. And the one that I'm going to make public is my update time. So I'll say public float target update time. And I will default this to 2. And put a note here to myself and anybody who comes along. Time in seconds. Always put little notes like this in. It just helps. I mean, what does that 2 represent? Does that mean 2 seconds? Does that mean 2 minutes? Does it mean 2 hours? 2 what? So it's always a good idea to put in little comments like that to make sure things are crystal clear. Alright, so there's, oops, and I forgot to initialize FPS. Now I guess I could do this initialization inside a start, but you know, for initializing just plain old value types like this, I usually prefer to do them up here, but that's personal coding preference. Alright, our update method. So going back to look at my logic here real quick, I need to update my time and update my frames. Alright, so let's get that done. Frame count's pretty easy. We'll just do a frame count plus plus. Elapsed time. We'll do a plus equals with time dot delta time, which gives us our time since the last frame that we are in here in the update method. Now I can check to see, do I need to actually update my frames per second? So if my elapsed time is greater than my target update time, and autocomplete is so awesome, well then I need to do that little bit of logic there. So let's see here, we need to update my FPS. FPS is going to equal, oops, mathf dot floor to int. I don't actually want to round up. I mean, if it's a partial frame, I want to throw it out. So I'm going to floor to int, and I'm going to say, see here, my frame count divided by my elapsed time. Reset my frame count to 0. Now in the elapsed time we got 2 options here. We can set it to 0 or we can set it to our target minus elapsed time. It depends on how accurate you want things to be. If you just set elapsed time to 0, you are losing out on fractions of seconds there because it's never going to perfectly equal your target time there. On the other hand, if you don't particularly care about losing fractions of a second, which arguably we really shouldn't need to worry about that, you could just simply set to 0. I'm going for the paranoid route, so I'm going to say elapsed time equals target update time minus elapsed time. And as far as waiting for the next frame, well, that's just sort of handled by falling out. Now I need to see if this is actually working. So for the quick method here, I am going to simply say print FPS plus FPS. Oops. The print method, remember that will put things out to our console in Unity. So hopping back over here to Unity, make sure I attach this to my main camera. Look at my main camera, verify that, yep, okay, it's there, update time of 2. And this is why I made this public. Remember, anytime you make something public in a monobehavior object, it will show up in the editor, assuming the editor can understand the data type. So I've got that, so it looks good, hit the play button. And then looking down here at my console bar, yep, there it goes. I'm getting my frames per second. Now, when you calculate your frames per second this way, it is always going to differ a little bit from the frames per second that the Unity stats thing here gives you. I don't have an explanation for this. They should be the same, plus or minus 1, but they're not. And I honestly can't explain it. I don't know what the difference is in calculations. So there is that, but it is accurate enough. You know, 60 is actually pretty much what I expect to see, given the refresh rate on my monitor. Now, if you click on this bar down here, you can pop up the console, and usually what I do on projects is I maintain the console as a tab over here, so that way I can easily take a look at it and see what's going on. And we can see here it's moving once every 2 seconds, so great, it's awesome. Now, how do you desynchronize it from the vertical refresh? Well, that's fairly simple. You need to go into Edit, Project Settings, Quality, and on your default quality levels here, good. Need to come down here and vSeek count. Just tell it, don't sync. Now when I run it, I'm getting full unbridled power. Again, you can see here there's some differences in how it's actually calculating. That's actually a bit more of a sane number there. This is only because there's absolutely nothing in the scene. We just toss in a couple of quick things. Toss in a cube here, move him so he's actually in the camera range, and toss in point light, so there's actually some lighting calculations to do. Well, kind of sort of pulls it down to a sane range there. No, okay, I'm going to stop trying to make it sane. And the point being is we've got, a working frames per second counter here. Now, you might not have access to the console. Maybe you are running this in a release build mode, in which case you're not going to have access to stats, you're not going to have access to the console, but you still want to be able to see what your frames per second is. And you don't want to use an external program like, say, Fraps to be able to see this. So, what can we do? Alright, well, let's add a little bit of extra functionality in here. So let's hop back over to our code here. There we go. Now, let's say we want to put this in a label. All of our label stuff needs to go into onGUI. Capitalization is important on this, otherwise Unity will not pick up on it. And there's going to be a full GUI video later. But for now, let's just take the easy way. We're going to use a GUI layout. Oh, hiccups, go away. I'm recording right now. So we're going to do a GUI layout. And we're just going to do a basic label. I'm going to say FPS plus FPS. So now when we run Unity, we get a little FPS counter up here in the upper left corner of our screen. Alright, so now what can we do to toggle this? Options are always good. Maybe we don't always want it to go into the console, maybe we don't always want it showing in the window. So let's add a couple of toggles here. And we'll make these public because this is something we would want to alter in the editor, not having to come into code. So we'll say public bool show in console. We'll default that to true. And public bool show in label. And we'll set that to true as well. And then just some basic logic down here. We'll say if show in console. And same thing here, if show in label. And now I can toggle this. So if I select my camera and I go back over to my inspector, I can turn off my label, turn my label back on, turn off the console, which of course that's a little bit harder to see. If I select something, you can see now I'm not getting any more updates to the console. If I go back over here and turn that back on, hop back over here, now you can see that, okay, I'm getting updates again. Turn everything off, and I'm not getting anything. Could also be useful too for saying, yeah, all right, well, I want a very rapid update, so I'm going to change this to 1. You can see my updates are coming faster. If you're going to change, like say completely delete everything out, you want to be careful with that. Usually when you're doing numbers, you want to pause it before you actually say go in here and delete everything out, because that can cause confusion for Unity. So I'm going to change it so that I'm updating it every quarter of a second. Unpause it. And now you can see, yeah, I'm updating every quarter of a second now. And getting much more sensitive results because of that. And of course, always keeping in mind in Unity, any changes you make while Unity is in test mode, while it's running, those changes will be undone once you stop and go back to the editor. So my target update time has gone back to 2, and of course, showing console and showing label are now back to their default values. Very important to remember that. That does cause quite a bit of confusion at times. All right, and that's the simple frames per second counter. Always remember, regardless of how simple the logic is, it never hurts to take 5-10 minutes to draw out the logic in the state machiner, however you want to do it. Star UML is an excellent way of doing this on the computer. It does take time to learn Star UML, and honestly, a piece of paper works just as fine. It's just, I don't know, for me, pieces of paper are a little bit harder to keep track of, to be honest. All right, so that covers a frames per second and a rapid-fire introduction to Unity scripting, and more tutorials to follow.